Hello, everybody. I just wanted to give you a quick video on understanding net force, which is what we will be getting into this week. So, last week we read about force, and specifically, you did some activities with friction. Remember, friction is a force that goes against the motion of an object. Friction is what we call a contact force, meaning it comes into contact with the object directly. Shoving your friend into the locker would be an example of a contact force where two objects are directly touching each other. So friction will slow an object down because it's going to go against the motion of an object. Some forces that you also read about are non-contact forces, meaning that they are forces that act at a distance. So an example of a non-contact force would be gravity, or magnetic force is another good example where magnets do not need to touch one another to feel the force attracting or repelling them from one another. So contact forces touch, non-contact forces do not. Now, one of the things that we will talk about this week are forces, and forces always have two things. They have a magnitude and they have direction. Magnitude is another word for the strength of a force. Now, you've read that the unit of the force is a Newton, and we measure the magnitude of forces with newtons, and we're going to abbreviate this unit with a capital letter N. You never want to write a lowercase n for Newton. It's always a capital N. Also, forces have a direction. So in physics, we use something called free body diagrams, where you're going to see arrows to show the direction of forces. And one of the important things to remember is the longer the arrow, the more magnitude or the more strength that force has. So what is net force? Net force is the total amount of force acting on an object. And when we calculate net force, we need to look at the direction of the forces. So if my object is this orange box here, and my forces are shown with arrows, this arrow is shorter, this arrow is a little bit longer, which would distinguish that this force of the longer arrow has more strength, would have a higher number of newtons than the shorter arrow, but they're moving in the same direction. So imagine if you're pushing on this box and your friend is pushing on this box and you're pushing it both in the same direction. You're going to add those forces together if they're in the same direction to find the net force. If your forces are acting in different directions, so here's a yellow object, and let's say you're pushing from one end of the box on the left side, and on the right side of the box, your friend is pushing against you. To find the net force on different directions, you're going to subtract them. So here's an example. This is an example of a free body diagram. You're going to see the object, and you're going to see the direction of the force with an arrow. And I can see that this object is being pulled with a force of 3 newtons to the right, and also has an additional force going to the right of 5 newtons. So because these two forces are in the same direction, they're both going to the right, I am going to add those numbers together to find the net force. So 3 newtons plus the 5 newtons gives me a total net force of 8 newtons. And net force also has to have a direction. So this object is going to move to the right. So again, if they're in the same direction, we add them. Now, if my net force is opposite, so in this example, I have an object with two different forces acting upon it. One is going to the left with a greater force of 4 newtons, and the object is also being pulled to the right with a weaker force of 2 newtons. So these are not acting in the same direction, but they are opposite of each other. So to do this, I want to subtract the smaller number from the larger number. So 4 newtons minus 2 newtons gives me a net force of 2 newtons. Remember, that's the overall force acting on the object. There are 2 newtons of force acting on this object, and those 2 newtons of force are moving to the left because this is bigger, stronger. It kind of overtakes the 2 newtons to the right. So it's going to move 2 newtons to the left. Now here are a couple other examples of calculating net force. Sometimes you will have more than 2 forces acting on an object. So in this top diagram, I have a force acting up on the object, a force acting down on the object, a force acting to the left, and a force acting to the right. Now, if I start with the 2 opposite forces here, up and down, 2 newtons up and 2 newtons down cancel each other out. So you would still subtract those because they are opposite. 2 newtons up minus 2 newtons down gives me a net force of 0 newtons. So whenever you have a net force of 0, what we call that is a balanced force. That they kind of cancel each other out. There's no motion. It's not moving up or down because they're equal. Then I would take the 2 opposite forces on either side and I would subtract those. So I have a stronger force of 4 newtons pulling it to the right and a weaker force of 2 newtons pulling it to the left. So 4 minus 2 gives me a net force of 2 newtons to the right. So overall, on this object, even though there's 4 forces acting on it, the net force is 2 newtons to the right. In the bottom example, I have another object that has, get rid of that, oops. I have another object that has a force of 3 newtons moving up and 1 newton moving down. So if I find those opposites first by subtracting, 3 minus 1 gives me a grand total of 2 newtons up acting on that object. And then these are also opposite forces, so I'd have 3 newtons to the right, 1 newton to the left. I'm going to subtract those. 3 minus 1 is 2. The direction is always going to be in favor of the larger force. So this is going to be 2 newtons to the right. So for this one, my grand total net force is actually in 2 directions. I have a force acting 2 newtons up and a force acting 2 newtons to the right. So sometimes that is the case if they are not balanced. And I have one more example for you. Sometimes you might have an object that has forces that are the same on one side and then an opposing force on the opposite side. So if these are what you're faced with, it's simple. You're going to follow the same rule that if my forces are in the same direction, I am going to add them. So 2 newtons to the right plus 4 newtons to the right gives me a grand total on this side of 6 newtons of force moving it to the right. And opposing that is 1 newton of force pulling to the left. So I take the total here, 4 plus 2 is 6 newtons on the right side, minus the 1 newton on the left side gives me a net force of 5 newtons to the right. So I hope that helps. Come back and watch this video again. You're going to have some problems calculating net force, but that is the basic premise of it. You have to look at the directions of your forces. So again, if they're moving in the same direction, you add them. If they're opposites, you subtract them. Let me know if you have any questions.